Hey, and welcome to this lesson video for solving equations of quadratic form. So that's exactly what our learning target is, and let's kind of see what this even means. There we go. So first, I want you to look at this chart and just tell me what you notice. I'm going to compare a larger number of 2 to a smaller number of 1. Compare larger number 4 to smaller 2. 1 to 1/2. 2/3 to 1/3, 2/5 to 1/5. What observation do you make? Well, what's happening is the larger number is double the smaller, or in other words, the smaller number is half of the larger, okay? The smaller number, okay, so again, the smaller number is half of the larger. You might not be convinced though. You're like, are you sure this 2/3 and this 2/5 deal? Well, if you think about it, 2/3, how do you get it? Isn't it true that 1/3 plus 1/3 is equivalent to 2/3? So 1/3 is definitely half of the combination, 1/3 plus 1/3. Same with 2/5. 2/5 comes from a fifth plus a fifth, so yes, 1/5 is half of that number. What does this matter though? Well, that's kind of the basis of quadratic form. Okay, let me go back. A regular quadratic looks like this: x squared plus, 3x plus 2. This is quadratic because it has the x squared. And remember that the middle x is understood to have a power of 1. So between the two powers on the variables, 2 and 1, it's kind of this scenario happening right here. The larger power, okay, and the smaller power. The smaller is half the value of the larger, okay? So this is a quadratic. This is obviously definitely quadratic form, but I could technically argue that x to the 4th plus 3x squared plus 2. So the same kind of expression here, except the powers on x changed. The powers changed to a 4 and a 2. However, the smaller power 2 is half of the larger, so this is also quadratic form. Okay, if the smaller is half the larger, then it's considered to be quadratic form. So that's kind of the whole basis of what we're talking about. So here I say, again, notice that the power of 1 on the middle x is half of the power of 2. All right, and we know that to factor this guy, we would do an x puzzle. What multiplies to -21 and adds to 4? Well, that would be a 7 and a -3. And when we factor this using these numbers, we do x plus 7, x minus 3, right? Because if I were to FOIL, the first would be x times x, which would be x squared, okay? So when we factor it down, we put x with the powers of 1. So in other words, kind of like the middle power is what starts our groupings for factoring, okay? So with that in mind, the way we factor can be applied to non-quadratic equations if they are of quadratic form. And we know that quadratic form is when the smaller exponent is half of the larger. So here's a more specific example. Let's get that guy out of the way. Looking at my powers, 2/3 and 1/3, remembering our chart, the smaller is half of the larger. So this is quadratic form, I'll just call it form. Okay, so think about the way we factor. There's understood 1 in front of that x with the largest power. So this would be just like an x puzzle. What multiplies to 4 and adds to -5? Let's see, -4 and -1. Two negatives multiply to the positive, but then add to the negative that I need. So here's the only difference when we think about factoring. Remember how we started with x, -4 or whatever? Well, we need the middle power to start our parentheses. X to the 1/3 minus 4, x to the 1/3 minus 1. You know, these numbers again are coming from the X puzzle. So that would take care of factoring, but it asked me to solve, so I need to keep going. And we know that since these two things multiply to 0, then one or both must be 0. So let's set these guys separately equal to 0. So x to the 1/3 minus 4 equals 0. X to the 1/3 minus 1 equals 0. And so then solve these guys real quick. You know, add 4, x to the 1/3 equals 4. And over here I would add 1. So x to the 1/3 equals 1. Now, here's the problem. 1/3. I need to get x alone, but how the heck do you get rid of a power that's a third? Well, you know, like if we have x squared, we take a square root, but that's not quite going to work for us. So here's what you need to remember. 1/3, if you think about power over a root, x has a power of 1 and a root of 3, this is basically like a cube root here. And so to get rid of a cube root, you cube it. Okay? So we're actually going to cube both sides, but cubing the left just cancels out the exponent and leaves me with x. And then just remember that this is not 4 times 3, this is 4 times 4 times 4, 4 cubed, which would be 64. So there's one x value. I'm going to do the same thing on the other side. I need to cube to get rid of that cube root. Okay, so those are gone. And so it's just simply x equals 1 times 1 times 1, which is 1. Okay, so this guy's solved. Now, here's another guy. Make sure he's quadratic form first. The smaller is definitely half the larger. The square is definitely half of the power of 4. So we can continue with our normal factoring methods. And since there's that 2 here, we have to think about our multiply and expand kind of factoring. So we need to remember that we multiply the first number times the last number. And, whoops, I guess, let's see, that product is going to be negative 18. Okay, now second step is to remember what two numbers will multiply to the first and add to the second. What factors of negative 18? Multiply to negative 18, add to a 3. I need one of each sign, so here's what I think I need. I think I need a positive 6 and a negative 3. So then here comes that expanding part. We're going to keep everything the same except that middle guy. We're going to kind of like unbreak him apart and replace the x squared term with 2 terms instead of 1. So in other words, 2x to the 4th, and instead of, combining like terms, we're breaking them apart. We're using these numbers. We're going to do 6x squared minus 3x squared. So that way, if I were to add them together, they would simplify to what the middle was in the original problem. Okay? And so remember that once we get this far, it's just a matter of grouping, factoring by grouping from here. Remember, we want a plus in the middle. So let's see. The first term, we want to factor out the GCF. What do they both share? They both share a 2, and they both share an x squared. And so what's going to be left? Well, 2 times 2 is a 2. I just need an x squared here. So if I think about distributing, I get back to 2x to the 4th. And I just need a 3 here. 2x squared times a 3 would get me back to 6x squared. Now, if I do the same thing over here, I notice that they both share a factor of 3, but I'm going to pull out a negative 3 since they're both negative. And so I would end up with x squared. Let's see, negative 3 times what would be negative 9? A positive 3. Okay, and so remember from here we just regroup. We do x squared plus 3, 2x squared minus 3. The outside stuff kind of smushed together, if you will, in this group here. But since we're solving, that equals 0 is still there. What that means is one of these groups, since they're multiplied, one of these groups or both are possibly 0. So I got to set each one apart equal to 0. to figure out what the x value is going to be. Okay, so over here I would subtract 3, so I get x squared equals negative 3. Over here I would add 3, and so 2x squared equals 3, divide by 2, x squared equals the fraction, and I'm running out of room, not good. Okay, so now these guys, I gotta get rid of the squares. Well, what does that? And sorry, let me go to a new page. So here's where we're at. We've got x squared equals negative 3, and we've got x squared equals 3/2. What we have to do is we have to take the square root. It's the only way to get rid of a square. Okay, so over here on the one that's on the left, x is going to equal, okay, remember plus or minus because we're solving, I, because the radical 3 was negative, so plus or minus I radical 3. So 2 of the roots are complex. Let's see what happens over here. I gotta again take the square root, just square root of top and bottom. Okay, so x is gonna equal square root of 3 divided by square root of 2. But you know, I'm gonna ask probably for a radical form in your answer, so can't have a radical at the bottom, so you gotta remember to rationalize. Square root of 2, square root of 2. And so going across the top, x cubed times x squared is simply square root of 3 times square root of 2 is square root of 6. I was saying x there for some reason. One of two things, you can go across. Square root of 2 times square root of 2 is square root of 4, which is what? 2. Or you could just remember the rule. A square root times itself is just going to be whatever the number was. Okay? Now from here, well, first of all, I need plus or minus. Almost forgot that. But second of all, I can't reduce this to a 3 because 6 is under a root house, 2 is not. So can't touch this. Gotta leave it alone. Okay? That's what it is. So we end up with 4 roots. 2 of them are imaginary. 2 of them are real. It's just radical form. And so then that second example is done. Let's see. Yeah, I'll skip that for now. Watching my clock, I think I'm going to end here. So, that's it for this video. Next one you might want to watch is graphing standard form. But keep learning, have fun, and I'll see you next time.